Okay, what I'm going to show you now is how we're going to introduce an Arduino microcontroller to our Tinkercad circuits. So essentially what we need to figure out is what this device is. Essentially it's a programmable chip that's embedded onto a circuit board, and what it allows us to do is just like when we were building our circuits with a breadboard, it allows us to prototype and build different circuits using a variety of pins. In the last little talk, I spoke about digital versus analog. And so essentially it's split into four categories. If we're talking about input, we're talking about either analog input or digital input. If it's a digital side or a digital input, like a button, for example, we'd be hooking it up to this digital side. So any of these pins 2 through 13 would be used for digital. So in this case, we can use them either for input or output. Down here for analog input, if I was hooking up a potentiometer or that dial, rotary dial dimmer switch, I could hook that up to this analog side. Same thing with a temperature sensor or a light sensor. Anytime I'm reading in an analog value, so I'm reading from a sensor that's going to produce a bunch of different values, I would hook it up to this side. Any of our outputs are going to be on this side. The one thing you'll notice, and I'll talk about it a little bit more in a minute, but these pins that are labeled as PWM, the ones with the little squiggly lines next to it, those pins allow me to do analog output, not just digital output. So again, these pins 2 through 13 on this side would be for both digital and input and output. But this also allows for analog output as well in these PWM switches. PWM stands for pulse width modulation, and essentially what it does, because this is a computer, and we know that computers throughout the semester we've talked about how computers are purely digital. They only understand on and off. So what this device does, or this Arduino does, is it uses on and off very quickly at different rates with different delays through software to get the LEDs or the motors that we're going to be wiring up to these analog or PWM pins to be able to dim and not just be full brightness. So after I drag my Arduino on the board, I can also add a breadboard. Now when I run the simulation on the Arduino, it will automatically start the code. So we'll talk about the code a little bit more in a second. The one thing we need to realize is that before we had a power supply, we don't need the power supply because when I plug in and run the code for the Arduino, it will power up. So what I can do is I can use the power and ground from the board to hook up to my breadboard. So if I hook up black from ground, there's 2 ground pins there, I'm going to be using 5 volts, so I use 5 volts here, hook that up to power, and again, to be consistent on what we did with the breadboard before, is I would hook up power and ground here, and that will give power and ground so I can use either side of the board to do it. Now before, when we were receiving outputs from circuits, I would use the output pin and hook that up to an LED. This first example that we're going to do is showing how we can control those LEDs through code with the Arduino. So what I'm going to do is I'm going to hook it up to pin 13. So I'm going to have a wire coming out from pin 13 to my board. That one's a little messed up. Try that again. So from pin 13 to my breadboard. Again, when we're talking about outputs or the basic output, we're going to talk about LED. So I'm going to take an LED and I'm going to drag it in. Just like we did before, whatever my output is, and in this case this output is going to be coming from the Arduino, that hooks up to the anode side or the positive side of my LED. Turn this LED there. And again, similarly what we did before is we are going to need a resistor from the ground side or the cathode side of my LED. and then I just need to terminate that resistor down to ground. So by default, when I open up this code tab, and I do have a couple diagrams on EDSB as well, but if you open up this code area, by default it'll go to blocks. If you've done any programming before in Scratch, this will be somewhat familiar to you. Any of the examples that we're doing in this grade 11 course, you are going to be doing it with text code. So you can flip over to text. If you have some experience with drag and drop, you can look at block and text. That way you can kind of look at work in both worlds. But for now, we're going to use text. Now this area is where the code will be entered. By default, this basic setup for the blink LED automatically shows up. This code is already there for me. Typically speaking, when I'm actually running the examples that I'm providing for you, this text code that I have will allow me to open the text files that I provide you, and you can actually grab that whole section and drop that into and paste it into this text area of the Tinkercad. So in this case, it already has the basic code. The code that I provided to you is the same. It just has a little bit more comments, a little bit more information there for you. But the code is in fact the same. First, looking at the Arduino code, it's pretty straightforward. Even if you haven't done any coding before, the important thing to note in this code is that there's two sections of code. The first one is this void setup. The second one is the void loop. This void setup, this is very important, runs one time. So this section of code here only gets run one time. This here gives any information that the Arduino needs about your code before it gets started. So in this case, because I mentioned before that these pins 2 through 13 can be used either for output or input, the Arduino needs to know whether it's writing from that pin or it's going to listen at that pin for some sort of input. So because we're going to be controlling an LED, which is a digital output, I need to set the pin mode of pin 13, because that's the one I hooked up, to output. That way the Arduino knows it's going to send the signal out from that pin. So again, this section of code only runs one time. The next section of code is the void loop. And those that have taken programming before know that a loop is something that repeats itself. This section of code actually repeats itself forever. Okay, so essentially, as soon as I power up that Arduino, or in this case start the simulation, this section of code gets run forever. This runs one time to tell the information to the Arduino it needs. This section here will just repeat over and over and over again until I stop my simulation, or if I was working with a real Arduino, I would unplug the power. So how it would work with a regular Arduino is if once I upload that code, it actually gets stored on this chip, so that if I plug that Arduino in again somewhere else, just into power, it'll run the previous code that it has, so I can bring this anywhere I want and power it up, and it will run the code that's loaded on that chip. That chip is reprogrammable, meaning that if I write code to it and I want to change it, I can just upload new code, and that will be the newest version that it will run every time it gets powered up. So in this section of code, you can see that there are 4 lines of code. The first one here refers to a write. So because I'm controlling the LED, I'm going to write a value to it. Because I'm only going to be turning on or off, I use the word digital in front of that. It is case sensitive, so when you're writing this code, you need to be careful. The W is capital, so digital write, they're 2 words. The second word is capitalized. This tells it which pin it's going to be writing the value to, and this tells me what the value is. And in this case, because it's a digital, this is either only going to be high or low. There's 2 choices, just like we've been talking about in the binary unit. In the hardware unit, computers only understand on and off. So in this case, on would be high and off would be low. So this writes that value to that pin. Then this tells the computer to delay or wait. So it waits 1 millisecond so that our eyes have a chance to see it, and then it will wait a second, do the next section, which then turns the LED off, waits a second, and because this is in the loop that repeats forever, this will just repeat over and over until I stop the simulation. So again, when I run this code, you can see that my LED turns on for a second, off for a second, on for a second, off for a second, and that would repeat as long as I want to sit here. Okay. The one thing I want you to realize as well, that as I mentioned before, any of these pins that have a little squiggly line, I not only can do digital output, but I can also do analog output. So one of the extensions that you're going to do for this first circuit, it says to switch it to pin 9. And the reason why it's using pin 9 is because it does have one of those little squigglies. I could use pin 3, I could use pin 5, I could use pin 6, it doesn't really matter. So because I'm going to use pin 3, again in your example it might tell you to use a different pin, it doesn't really matter as long as it's one of the pins with the squiggly line. So now instead of setting pin 13 to output, I'm going to set pin 3 to output. The only thing that changes down here is that instead of writing digital write, because now I want to be able to do it in analog, I'm going to tell it to be analog write. So what changes here is obviously I've switched it to pin 3, so I'm going to change pin 13 to pin 3. And now instead of using high or low, I need to give this analog write a value anywhere between 0, which would be off, and 255, which would be full on. So now what I want to do, instead of just turning the LED completely on and off like I was doing before, I'm actually going to do it bright and dim. So instead of completely off, it would be, say, like turning your brights on in your vehicle and turning it to normal brightness. So I'll need to change this digital write to also say analog write. I'm going to change this to pin 3 because that's the one that I'm using now. And instead of doing all the way down to low, I may say about half at 127. Okay, so the only thing I've changed is the way that I'm writing. Again, straightforward, either digital or analog. If it's digital, the only choice I have for a value that I'm writing to it are high or low. If it's analog, that can be anywhere between 0 and 255. So now when I start my simulation, it'll be a little bit hard to see, but you can see instead of turning completely on or off, you can see it's just slightly dimming that LED. So it's going from full brightness to half brightness. Okay, so that's using analog with that write.